Okay, so today we are going to talk about measuring mass with the mole. And basically we're going to calculate molar mass of something and then be able to calculate that mass and give the number of moles and be able to do this equation backwards and forwards. So atomic mass versus molar mass, the numbers really are the same. It's just the units that are changing. So for example, the atomic mass of, let's say, phosphorus is going to be 30.974. Whereas you look at the molar mass, it's also, for phosphorus, can you see? It's also 30.974. The only thing that's changing are the units. So with molar mass, the units are grams, and with atomic mass, the units are AMUs. Those you have both been exposed to, so they should be pretty familiar. So we're going to look at molar mass examples. So we're going to look at how to calculate molar mass. All right, so we're going to look at the molar mass of aluminum sulfide first. So aluminum sulfide. So all we're going to do is look at the atomic mass of each and then multiply it by how many there are and then add them together to find out the molar mass of a molecule. Okay, so it's easy to find the molar mass of an atom. All you do is look at the atomic mass and change the unit. But for molar mass of a molecule, you just add how many of that atom there are in the molecule and then add them all up together. So I like to solve the equation by just writing aluminum, the different atoms that we have in the molecule. We have aluminum and we have sulfide atoms, or ions actually. So aluminum, we have 2 of them, and sulfurs, we have 3. Okay. So aluminum, we're going to find its atomic mass, which is 26.982. Okay, and then sulfur, its atomic mass is 32.06. We're just going to multiply, and then we will add them together. Okay, so we have 2 times 26.982, and the answer is 53.964. We're going to keep that number just like it is because of significant figures. So 53.964. And then we're going to calculate 3 times 32.06. And that's 96.18. Again, the significant figures are fine. Now we're just going to add these two together and we'll have our answer. So we're going to do 53 plus 964. 53.964 plus 96.18. And our answer is 150.144. And the units are grams since we are talking about molar mass. So 150.144. Now, we do need to take into consideration significant figures. So significant figures, we are adding, right? So we're not looking at numbers of significant figures, we're looking at digits past the decimal. So there are 2 digits past the decimal here, 3 digits past the decimal here. We need to choose the lowest digits past the decimal when we are adding. So that means this can only have 2 digits past the decimal, so it needs to be cut off here. We need to take into consideration whether this will round this up or keep it the same. It's going to stay the same because it is not 5 or greater, so we're just going to erase it, okay? So the answer is 150.14 grams. And that should be what our answer says, and it's close. So keep in mind on the test, when you look at the periodic table I give you, and you compare it to the periodic table on the wall, and you compare it to the periodic table on the internet, they'll all have different atomic masses, and that depends on when the periodic table was made and which isotopes it's taking into consideration. We learned about that in a previous unit. So my advice to you to make sure you're doing the correct significant figures and getting the correct answer is that you use the periodic table that is stapled to your test. That way you will have the correct answer. So that's why I encourage you guys not to look back at the back of the wall at the periodic table. That way, for one, you won't be accused of cheating, and for two, you'll be using the correct number, atomic mass number. Okay, so we're going to look at another example. Atomic mass of barium phosphate. So Ba3 PO4 2. So again, I like to start out by writing all of my atoms that I have in my molecule. We have barium, we have phosphorus, and we have oxygen. And we need to write the number that we have of each. So we have 3 barium atoms, we have 1 phosphorus atom here, but we're going to multiply it by 2 because there's a 2, this 2 applies to everything in the parentheses. This is simple math, so I shouldn't have to explain that. So we have 2 phosphorus atoms, and then we also have 4 oxygen atoms, but again, everything in parentheses needs to be multiplied by 2, so we actually have 8 oxygen atoms. So now we're going to just write down how much it weighs. So barium has a molar mass of 137.33. Phosphorus has an atomic mass of 30.974. And oxygen has an atomic mass of 15.999. So we're just going to send them over here, add them, and we'll have our answer. Okay. So, calculator, go. So first one, 3 times 137.33, and that's 411.99. Okay, next, phosphorus, 2 times 30.974. I am checking my significant figures as I do this. There's 5 here, there's 5 here, there's 5 here, there's 5 here, so I haven't changed anything from my calculator. And then 8 times 15.999. Now this one we will have to change. So we have 5 significant figures here, so we need 5 here, so we're going to have to cut off the 2. It's not going to round the 9 up, so we're just going to cut it off. So we have 127.99. All right, we have our numbers. We're just going to add these, and then we should have our answer. So 127.99 plus 61.948 plus 411.99. That gives us 601 point, we're adding, so we need to take into consideration digits past the decimal. So we have 2 here, 3 here, 2 here. The lowest number is 2, so we want to go no further than 2. This is not 0.928. 8 will round that 2 up, so we're going to say 0.92. And our answer is in grams. So the molar mass of barium phosphate is 601.92 grams. Okay. And again, the answer is deviating because the periodic table I used in the past was different than this one. So just again, make sure you use the numbers on the periodic table and you should be just fine. So this is how many grams 1 mole of this stuff, the barium phosphate weighs. So for every 1 mole, this molecule or this substance will weigh this many grams. All right, so now we're actually doing a calculation with molar mass. So it's giving us moles, and then we have to do a calculation with it. So it's asking, what is the mass of 1.33 moles of barium phosphate? So this is where we use dimensional analysis. So, or that's what I use to solve these. So the unknown and the known, we have an unknown. Actually, it's best that we write the known first, my bad. But our unknown, what we're trying to find is what is the mass of Ba3PO42. So it's asking what's the mass of this substance if we have 1.33 moles. Remember, a mole is just like saying a dozen. So if we have a dozen eggs, how much would it weigh? So that's kind of what we're saying, except we're talking about moles now instead of dozen in this example. So moles of Ba3PO4. 2. Okay, so with dimensional analysis, we just start with our known, right? We've done this before at the beginning of the school year, except we used various units. It's just a conversion factor. So 1.33 moles of Ba3PO42, and we're multiplying. So whatever's up here, remember, must go down here. Mole of Ba3PO4. 2. So remember yesterday, our last lesson, we had particles up here. Well, the question's not asking for particles, right? It's asking for mass. We happen to have just calculated the atomic mass of this substance, so I'm not going to do it again. We're just going to use the mass that we have, which will be different than the PowerPoint slightly, so don't freak out when our answers vary a little bit. So it's 601.92 grams. So that's the molar mass of grams of Ba3PO42. So basically for every 1 mole, like we calculated here, for every 1 mole, we have 601.92 grams. So we're going to put it here, 601.92 grams of that. And now we just plug it into the calculator and our answer will be our answer. So remember, if there is a 1 at the bottom, we're just taking this number multiplying by this number because it's just, this is a whole number. So if it's a 1, we just ignore it. If this number was down here, it would be this divided by this. We don't have to put in parentheses this number over 1. We don't have to do that. You can if you want, if you just need to have that organized. But how I do it is I just take 1.33 times 601.92. And I have an error. 1.33 times 601. Oh, that's what I did. Delete, delete. I'm putting a decimal instead of 1. 601.92. Okay, now it's happy. So the answer is 800. And I'm going to go ahead and, instead of write the whole thing and then rewrite it, I'm going to look at my significant figures. The calculator says 800.5536. I don't know if you can see that as the answer. So I'm going to look at my significant figures. We're multiplying this time and not adding, so we're not looking at digits past the decimal. We're actually looking at total number of significant figures. Here, the total number is 3. And here, the total number is 5. So really, we could stop at 800, like the single digit, and the 5 would round the 0 up to 1. So I went a little too far. So it should just be 801. These units canceled out. Okay, so they're gone, and we are left with grams of Ba3PO42. And that should be our answer. Let's see if we did it right. So yeah, we did it correctly. Okay, so that's that. Let's look at the next example. How many moles are equal to 157.8 grams of calcium chloride? All right, so they gave us the grams this time, and we need to calculate number of moles. So I like to write my known and unknown, known and unknown. So my known, which is just the number they give us in the problem, is 157.8 grams of CaCl2. Our unknown, which is basically what it's asking for, is how many moles of it are equal to that, okay? So again, our problem will always start out with our known, which is 157.8 grams of CaCl2. And then we're going to do our equation. Whoops. Now, this will always go down here. So grams of CaCl2. And then up here is our known, unknown. So moles of CaCl2. So basically all we're going to do now is we're going to find out for every 1 mole how many grams we will have of calcium chloride. To do that, it's very simple. You just take, we have calcium and we have chloride, okay? Calcium and chloride. So calcium on the periodic table over here, it weighs, its molar mass is 40.078. We only have one of them, 40.078. And then chloride, 35.45. There's 2 of them. Okay, so we're just going to multiply and then we'll add the products and we'll be done. So this we just move over, right? 40.078 and then 35.45 times 2. So 35.45 times 2. 70.9. Okay. So we will add them together. That's 40.078 plus 70.9, 110.97. Really, we need to cut it off here. So we'll just say 111. Okay, so here 111. Now to calculate it, so this number, went here. That's how many grams calcium chloride weighs for every mole. This is just a conversion factor, just like at the beginning of class, or at the beginning of the school year. So we have 157.8. So now 1 is here, so we're ignoring this and we're dividing by this. So 157.8 divided by 111. And our answer is 1.42. So we have 3 significant figures here, 4 here. So 1.42, the 1 won't round. So we'll do 1.42. These units cancel, and we're left with moles of calcium chloride. All right, so that's how you calculate molar mass, and that's how you use molar mass to find out the number of moles of each molecule. So practice with the homework. You can practice it on your own and come to class with questions, or you can come to class and we will have time to work on your homework.